Next, we're going to talk about vector operations, just add, subtract, that kind of thing. And this is one of the easier parts of the lesson. But look at example 5. You've got vector u and vector v. We're going to add them. So really all you do, and you can do this in your head, but just add the parts. Add the x terms, negative 2 plus 4 is 2, and add the y terms, 1 plus 3 is 4. That's all you do. Now when we multiply, maybe it's even easier, we're going to multiply negative 2 times the u vector. And so, I don't know that you need to write this, but I guess you could. It's kind of like distributive property, I suppose, but we're just multiplying each piece of the vector by negative 2. We're going to get negative 2 times negative 2 is positive 4. Negative 2 times 1 is negative 2. Now the last one here is a little bit harder. Sometimes people mess that one up. It's got 2 steps to it, so make sure you do 2 steps. We've got 4u, and so do that in your head. Take that u and multiply it by 4. So 4 times that u is going to be negative 8, 4. And then we're going to do 3v. So take that v and multiply by 3. We've got 12, 9. We're going to subtract those 2 vectors. Okay, so the last step, we'd have to take what we just got and subtract it. So that's fine. Negative 8, subtract your parts. Negative 8 minus 12 is negative 20. 4 minus 9 is negative 5. So we would have the vector negative 20, comma 5. Talk about unit vectors. When we talk about a unit vector, it's going to have a magnitude of 1. Okay, so right here is a unit vector. It has a magnitude of 1, and right here, the unit vector, it has a magnitude of 1. Really, anything along the unit circle. It doesn't have to be at a 90-degree angle. This could be a unit vector because it has a magnitude of 1. So anything that has a magnitude of 1 could be a unit vector. Then they introduced this other terminology, 3i plus 4j is the same thing as 3 comma 4. Okay, it's the same thing. So if I give you a vector 6, 8, you might have to write it as 6i plus 8j. It's just important to notice the x part is 6 and the y part is 8. It's really hard to mess that up, I think. Dot product. Dot product is really important. It's going to tell us some stuff about the angles between 2 vectors. Here's how you calculate it. U dot v. Now you might notice that that symbol looks an awful lot like multiplication, but it's not quite the same thing. Not quite the same symbol as multiplication. Do not say u times v. You're going to say u dot v for the dot product. U dot v equals, and so notice over here you've got these 2 vectors. We're going to dot product those. Really all you do is you multiply those and multiply those and add them together. So it's going to be AC plus BD. This is a number. Not a vector. It's just going to be a number. And that number is going to tell us something about the angle between 2 vectors. So example 6. Example 6a, we're going to find this dot product. Really all we have to do is multiply these 2. That's 8. And multiply these 2. That's negative 3. So 8 plus negative 3 is 5. That's it. That's the dot product. Okay? Now what that tells me, we'll go more into it later maybe, but that number, when it's positive, tell me that it's an acute angle. An acute angle in between the 2 vectors. So is anybody ahead of me and already done the next one? What did you get? 0. Good. You have 6 times negative 2 is negative 12, plus 4 times 3 is 12. You've got a dot product of 0. Okay? 0. That's an important one. 0 is going to indicate this word called orthogonal Orthogonal seems like a really tough word, but when it says orthogonal, that means basically we're talking about a 90-degree angle. Okay? There is a 90-degree angle between the two vectors. So we could draw them out, but once we draw them, you're going to see there's a 90-degree angle between the two vectors. A negative dot product would indicate an obtuse angle. When we saw positive was acute, and 0 was orthogonal or 90 degrees, but a negative answer would have been